Welcome back! In today's video I'm going to start a very big project, and that is making Cubane. Cubane is very interesting because it's basically forming a cube out of carbon atoms, and these carbon atoms are bonded at a 90-degree angle, and usually this kind of bond angle is very strained and makes molecules very unstable. However, this molecule is surprisingly stable and you can make a lot of organic compounds with it. Making this compound is really not an original idea. The first one to actually do it on YouTube is Tom on his channel Extractions and Air. And the first one to actually finish the synthesis is the channel Chemiolus. And after that, or in between that, a lot of other channels are making videos about synthesizing this molecule. However, I still think it's a very fun synthesis where you can incorporate your own ideas and stuff and hopefully make some of this compound. This is still very expensive, so yeah, maybe we can do more chemistry with it once we actually have it. I think that would be original because as far as I know, everyone on YouTube is actually only trying to make this compound rather than to use it and make other molecules with it. So I think that's the goal for this video, to have some Cubane and make some other compounds with it. So the reaction scheme of this synthesis looks like this. So it's not that easy, and I kind of want to do it on a scale like Tom on his channel Extractions and Air. He's actually working on a very large scale, and I'm trying to kind of match this. So like everyone else, I'm going to start this synthesis with adipic acid. Adipic acid is, I think, a food preservative, and it's somewhat easy to get. It's non-hazardous and stuff. And the first step is to take this and turn it into cyclopentanone. One problem is I can't really do it inside here in my workshop room because this is in my home. I could do it in my friend's film hut. We filmed some videos there, but obviously he needs to have time for that. And I have to see, yeah, that's kind of the first problem. Like, I have to go outside, maybe on the balcony. I think that's a bad idea. So that's the first thing. I have to see where to do this actually. So what I'm starting with is 3 times 250 grams of adipic acid. So 750 grams in total. And what I need to do is I need to put this in a round bottom flask. And I need to heat this up to 300 degrees Celsius with a bit of barium carbonate. And the barium carbonate will act as a catalyst for the decarboxylation and cyclization of the adipic acid, and this will turn it into the cyclopentanone. So I did order a 1 liter round bottom flask, but it hasn't arrived yet, so the only one I have is 500 milliliters. So I think what I'm going to do is maybe only use one. Yeah, only use one of these and first test out the reaction. So I think that's a good idea. Do it at a smaller scale, and when that works, then I will do the rest. Yeah, let's do that. All right, I calculated from the Chemiolus video how much barium I need. He used barium hydroxide, I used barium carbonate, so I just recalculated it, and let's weigh this in. Okay, this should be fine. I need 5.2 grams of barium carbonate, so that's all right, I guess. I'm going to put this in here. Right, and I'm going to shake this around. Whoopsie, we actually need 5.6, so I'm adding another around 0.4 grams. Shouldn't really matter though that much. Alright, everything is set up. I kind of forgot to weigh the adipic acid. I just trusted the supplier that this is 250 grams, but let's just put it on the scale and subtract the container and the barium carbonate that I added. So let's, seems like it's 320 grams. Okay. Let's put this in there and start heating it up. Okay, that's in, but I just realized I need some boiling stones or something in there. And I have nothing here, so I need to find something. Ooh, this looks perfect. Yes, sand. Oh, perfect. I'm going to get this. I think that's enough. Perfect. Just some sand from the road. Probably could have smashed some glass as well, but oh well. Just get some sand. So everything seems to be working and it's distilling at a reasonable rate. Let's see how long this is going to take, because I kind of started this a bit late, but let's see. It's getting closer now to the end of the distillation. There's not much in there, and that's what I have collected so far. It's not that much, I think, but who knows, I don't know. It's only 250 grams, so let's see how much I will get when I do the rest of the adipic acid. So I'm processing the rest of the adipic acid right now, and yeah, I still have 500 grams left, and this is just too much for this flask. I did order a bigger one, but it hasn't arrived yet. So I can't really do anything but to do this in 2 more batches. A bit annoying, but either I wait for the bigger flask or do it right now. So let's just do it and get this done. I think this time I got a little bit more product, but I still have to go through some of the adipic acid. I think there's like 200 grams left, so I have to do another distillation. Heck yeah, look at that! The new glassware arrived. Let's do a quick unboxing. These are just stoppers. Yeah, 1 liter round bottom. I needed this like, I don't know, 5 days ago. At least I have now a big enough round bottom to actually do the distillation in one go and not having to do this 3 times. So that's that. And a separatory funnel. This I actually need as well right now for the next step. So that's very good that I have this now. So yeah, that's all the glassware I got here. I think somewhere in the comments someone asked how can I actually afford all of this, and I guess I basically save up a lot of money, and I'm still editing on my pretty broken laptop, and I'm also trying to offset the cost a little bit with sponsorships. But if you would like to donate, I do have these super thanks turned on YouTube, and I might even do like these channel memberships. But if you want to donate to this channel, this would be a huge help and I would be super grateful. But yeah, let's move on with the chemistry. So this is everything I've collected from the distillation. However, the reaction produces water, so this is still full of water. So I need to dry the cyclopentanone, and for that I'm going to use bolognese sauce. No, just kidding. Obviously, this is sodium carbonate, and I've dried this, so this is dry sodium carbonate. I will put this in there, and I may have to use the separatory funnel because I think it also like separates or helps separate the water and the cyclopentanone, but I will see how this works. Let's for now use only this one. Alright, so far so good, I guess. This also reacts with any adipic acid that made it over into the receiving flask. Yeah. Let's add some more. It doesn't seem to separate any water out of there. Seems like the sodium carbonate is holding onto the water. So I might not have to use the separatory funnel. Let's add some more. God damn it, it's so windy. Hope it doesn't start to rain. Anyway, the cyclopentanone is still cloudy. I put heaps of sodium carbonate in there and it's supposed to get clear, I think, but I put so much in there already. So let's just add this to the separatory funnel, filter this, see if there's any water separating out, and yeah, let's see how this works, or if I just removed all of the water with this step already. Have I removed all of the water, or is there still water in there? It's definitely not separating out. This is the part where I realize I actually have no idea what I'm doing. And if you also have no idea what I'm doing, but want to learn more about science, you should check out Brilliant, the sponsor of this video. I've never really been good at math, but messing up any calculations for these reactions can be detrimental. So I tried Brilliant's mathematics courses to refresh my knowledge and get some practice. I'm really happy how Brilliant walks you through their courses step by step and with increased difficulty. So no matter where you're starting, Brilliant makes it easy and effective to improve yourself. Brilliant helps you become a better thinker and problem solver. With thousands of visual interactive lessons in math, science, programming, data analysis and AI. You can get started for free by scanning the QR code or clicking the link in the description. And when you sign up, you also get a 20% discount on their annual premium membership. Thanks to Brilliant for sponsoring this video. Okay, there's nothing separating out, so I just decided to drain this into the round bottom for the next step. So let's just do that. This looks like less than I thought I had. I really hope I didn't lose a lot, but anyway, let's keep going, and the next step is to actually do another distillation because the stuff is still A, cloudy, and B, still pretty yellow, so it needs to be redistilled. So let's get this going. So you can see that the temperature is steadily rising, and I'm measuring the temperature up here. And that means that the composition of the vapor is steadily changing towards having more cyclopentanone and less water. And right now I'm just collecting the mix of cyclopentanone and water, and when it reaches like 130 degrees I will swap this container and collect the pure cyclopentanone. God damn it, the temperature was rising really fast and some yellow stuff started coming over, and I'm not sure if you can see that, but it's slightly yellow. At least the distillation went pretty fast. I also have this. This is actually, if you shake it, you can see the bottom stuff is actually water. So the top stuff should be cyclopentanone. So I think since the distillation was relatively fast, I'm going to use the separatory funnel on this, decant the water layer, put this together with the other stuff, and redistill this again really quickly. Also, this is the boiling flask, and you can see all the crap in there and the yellowness that started to come over and ruin my cyclopentanone. And this is what I got from all of this distillation. This right here, this is some wet cyclopentanone, so I still have to dry it, or I could technically also use it as is. And this is 59 grams, and this is the bulk of the pretty dry cyclopentanone, and this is 191 grams. So in total I have 250 grams of cyclopentanone. This is a yield of 59.3%. Pretty okay. It's not a lot, so I think I will get some more adipic acid and will do like another batch of this at some point. But for now I will just continue with this. In fact, I will for now continue with this, I think, because for the next reaction I definitely want to check out how well it works and not go in with a complete batch here. Alright, I now have my cyclopentanone, and the next step is to turn it into the cyclopentanone ketal. And this is done by taking some ethylene glycol and reacting it with the cyclopentanone in a acid catalyst. And this is a equilibrium reaction that's producing water. And the way to drive this reaction forward is to remove this water. And this is done by a piece of glassware that's called Dienstag apparatus. And this is the Dienstag apparatus, and I'm going to explain this probably later how this works. But this was gifted to me, and it has a broken valve. I'm not sure if you can see the crack right there, but it has a broken valve down there and I need to fix that. So what I'm going to do is I'm going to take whatever this is, cut this off here and cut the old valve off, and then melt this on here, and then hopefully I have a fixed Dienstag apparatus and can do the reaction. I would like to sincerely apologize for the terrible job I've done connecting this, but you know, it works and that's what matters. God damn it. Stupid bloody weather. Yeah, that's the problem with doing chemistry outside. If it starts to rain, you're basically screwed. But the weather has improved and it's not supposed to rain. So let's quickly set up my stuff again and do the reaction, because it actually takes 12 hours and we have 1500 already and I have no idea how I'm supposed to do this, but let's just keep going. Alright, I have here a flask with 53 grams of ethylene glycol and I'm going to add the cyclopentanone to it, and the catalyst is p-toluene sulfonic acid. Alright, now that everything is going, I can explain how this works. So here's the reaction flask and I added some toluene to it. I already spilled it, it's toluene. And this is the Dean Stark apparatus and this sits on top. And I filled this right here also with toluene. And on top of that is a condenser. And the way this works is the toluene or the reaction will generate water and it will boil with the toluene over into here, will condense by the condenser, drip down in here, and the water is heavier than the toluene or denser than the toluene and will sink down, and the toluene will stay on top and will flow back into here. And this way we separate out the water from this reaction and drive this reaction forward. And unfortunately this reaction is supposed to take 12 hours. I have no idea how I'm going to do this because it's like late afternoon already and I don't know. Alright, it almost had 6.5 hours. I'm going to stop this now and return to this tomorrow, cover this up a little bit, but let's turn it off. So yesterday when I stopped the distillation it was slightly yellow, and when I checked on it this morning it looked like this. I think it looks worse on camera. It's pretty dark red. So I don't know what to think of that. 12 hours. Let's turn that off. Alright, the solution has now a really dark red color. I'm pretty sure that's not how it's supposed to be, but I'm going to continue with cleaning this up by following the Chemiolis video. So I'm going to put this in the separatory funnel and first wash it with 4% sodium hydroxide solution 3 times. And then 2 times saturated salt solution, and maybe this will improve this a little bit. And after all of this work, this is what I'm left with. Some impure cyclopentanone ketal. Now I still have to process the rest of the cyclopentanone, and I actually am still not done with the cleanup. This still has to go through a vacuum distillation, but this is relatively complicated and I will do this in the next video. So if you want to see the progress on this project, then subscribe, and until next time.